Hi, my name is Dr. Anderson and I'm here to teach you about kinetics. In chemistry, we think of kinetics as measuring the rate of a reaction. Now, what is the rate of a reaction? A rate of a reaction is the change in molarity over the change in time. We express rate in molarity, usually per second, or it could be per minute, or it could be any time component. Let's just say molarity per second. Now, let's think about rate. When you have A reacting with B to produce C, A and B are reactants. So in general, when we think of a reaction, we think that the reactants are disappearing. So this would be a negative rate. And C is the product. We think of that as forming, and that would be a positive rate. Remember, it is the change in molarity over change in time. So, let me remind you really quickly what molarity is. Molarity is a measure of the moles of solute divided by the liters of solution. So we think of it as something that you're putting in something else and dissolving it. Again, units of this would be molarity over liters. Now, in this lesson, we're going to go over the three main ways we think of rates. Number one, we view rates in terms of stoichiometry. Now, we've already covered the stoichiometry lesson, so you will see some similarities to that lesson here in the rates. So for example, let's say I had H2 gas reacting with N2 gas to produce NH3 gas. Now, let me give you 1 second. We always want to balance these equations. I'll give you 10-15 seconds to do that. So my quick way of balancing this is putting a 2 in front of the NH3. We then have our nitrogens balanced. We would put a 3 in front of the H2 and a 1 in front of the N2. Now, when we think about stoichiometry with respect to kinetics, you have to be given a rate of one of the components to determine the other components. For example, what if I gave you the rate of N2 is equal to -10 molar per second? So that is how fast N2 is disappearing over the course of the reaction. How can we determine the rate of formation of NH3, question mark, and how do we find the rate of disappearance of H2 from that information? We can use very simple stoichiometry, but let me remind you that when you have a reactant reacting, it's always a negative rate and forming is always positive. So we're going to do the calculations without the positive or negative. We're just going to do them with the numerical value. For example, let's say we're trying to convert N2 to NH3. So if you have 10 molar per second of N2, we can use dimensional analysis to find, let's say we go after H2. In the balanced equation, there are 3 moles of H2 for every 1 mole of N2. So when those react, that shows us that H2 is reacting at 30 molar per second, and that would be for H2. So that would be the rate of H2. Now remember, H2 is negative, so we have to manually put that in. So that's a negative 30 molar per second. And what if we want to go find the NH3? Again, let's start off with what they gave us and use stoichiometry. There are 2 moles of NH3 for every 1 mole of N2. So this is going to be a positive rate because it's the products. So that rate would be 20 molar per second for the formation of NH3. This ends the trial online session, and we will continue on with second and third ways of measuring rates next time. Thank you.